Hi everyone. This is our second part on factoring third degree polynomials. So in part one, I had you guys factor things that look like this. This is what we call a third degree polynomial, which means third degree means the highest power of x that you see in that problem is x to the third power, or x cubed. So I might ask you to factor something like this: x cubed plus 4x squared minus 11x minus 30. Now what I did in part one is I gave you guys two factors, and we practiced using synthetic division. So what we did is we did synthetic division to divide out the first factor I gave you. We chained it, did it again to divide out the second factor I gave you, and then what was left over is the third factor. Now what's different for part two is I'm only going to give you one. Instead of me giving you two parts of the answer and asking you to find just that third factor, I'm going to give you one of the factors, and you guys are going to have to try to find the other two. Now, here's the problem with that. Remember, we're starting with a third degree polynomial. So we're starting with an x cubed function. I'm giving you one factor, so we use synthetic division and take it out. Now remember, every time you use synthetic division, it lowers the power by 1. So at this point, what we're left with is called a quadratic, or an x squared equation. Now, you can't use synthetic division again because I didn't give you another one to do. You don't know what to try for synthetic division, what's going to work. So what we're going to do instead with that quadratic is we're going to factor it the old-fashioned way, the way I just reviewed with you guys a little bit ago. We spent a lot of time on first semester talking about how to factor quadratics. We'll go over it again in the example today. But basically, once you get from x cubed down to x squared, if you don't have that second given factor, if you don't know how to do synthetic division or what number to use for synthetic division, then just go ahead and factor it the old-fashioned way. Now, your final answer to the question is going to be all three factors together. It's number one, the one I gave you that you use synthetic division on, and after you factor the quadratic, it'll give you two more. So let's go ahead and do a full example so you guys can see exactly how this. Here's what our questions are going to look like today. It says factor x cubed plus 3x squared minus 18x minus 40 completely, given that, and see I only gave you one this time. I said given that x plus 5 is a factor. In part one I said given that x plus 5 and something else is a factor. So we had two different numbers to use for synthetic division. This time I only gave you one. So let's start working the question, and I think you guys will see what's going to happen here. Let me set up, because I still want to do synthetic division on the one I gave you. So I set up for synthetic division. I have 1x cubed. I have a positive 3x squared, so I'll put a positive 3 there. Minus 18x, I'll put a negative 18. And minus 40, so I'll put a negative 40. Then I look here. Now what I'm dividing is x plus 5. So remember, I changed the sign here. Since it's an x plus 5, I put a minus 5 out front. All right, my question is set up. I'm going to do the synthetic division. When you're doing synthetic division, the first number always just drops straight down. And then to get back up, you multiply by that number out front, the negative 5. So negative 5 times 1 is negative 5. Add. 3 plus negative 5 is negative 2. Multiply again. Negative 5 times negative 2 is positive 10. And add. Negative 18 plus positive 10 is negative 8. And then multiply one more time. Negative 5 times negative 8 is positive 40. And add, and we get a 0 at the end. A negative 40 and a positive 40 gives us 0. So we don't have anything else to use for synthetic division. We're done with the synthetic division part. Now, if you remember from when we did synthetic division, my original problem started with x cubed. I divided one factor out, so it's going to lower by 1. That means my answer starts with x squared. And after the x squared comes the x. After the x comes the constant, or the number part. And the 0 would be the remainder, but since it's a 0, we'll just throw it away. So what I have is 1x squared. I'm going to write it off to the side here. 1x squared, or just x squared. I have a minus 2x and a minus 8. Now, I can't use synthetic division anymore, but I don't need to. I can factor that like we did in first semester. So if I'm going to do this one by factoring, I'm going to set up like this. Remember, the factors always start with your variable, which is x in this question. And what I'm looking for right now is two numbers that multiply to give me -8 and add to give me -2. And remember, I said some of you guys may be at a point where you can kind of do it in your head and just start running through and figuring it out. But if you need to, take the multiplying one, -8, and make your factor tree. Say -8 could be +1 times -8 or -1 times +8. Those don't add up to -2. So my other choice would be 2 and 4. It could be +2 times -4 or -2 times +4. And the two of those that add up to -2 would be the +2 and the -4. So I found my numbers. Those are the numbers because, remember, 2 times -4 gives me -8, and 2 plus -4 gives me -2. So I'm going to put a +2 on one of my factors and a -4 on the other. Now, your final answer to this question is all three factors together. It's the x plus 5 that we factored out using synthetic division, and the x plus 2 and the x minus 4 that we got from factoring first semester way. You can put them in any order you want as long as you have the three correct factors. So we'll have an x plus 5, we'll have an x plus 2, and we'll have an x minus 4. And that's how you factor a third degree polynomial if I only give you one factor ahead of time. You use synthetic division on the one factor, and then you use our regular factoring on the quadratic.